Hello and welcome to a previously recorded version of TA Instruments TGA Quickstart training class. My name is Louis Wagesback and I'll be the instructor for this class. First thing I want to do is thank you for being a customer. At some point in time, either you or someone at your company has purchased equipment from us, and we appreciate that. This is one of a series of courses designed to ensure that you, our customers, get the maximum benefit out of your thermal analysis and or rheology instrumentation. We have courses for a wide variety of instruments, DSC, TGA, DMA, rheometers, plus some on the software, and more courses are being added all the time, so be sure to check our website for that. To hear the audio for this previously recorded seminar, you must have a sound card with speakers installed on your computer. There's also a couple other differences because this is recorded. One, you're going to see a little box that's the WebEx player controls. Those controls can be moved around your screen so they're out of the way and not hiding any of the information on the screen. But in that, you can pause the presentation, you can stop the presentation, restart the presentation, and you can also back up and fast forward. So that's one thing. That's the controls that you have. Also, since it's previously recorded, there's not a live instructor that you can ask questions of. But what we can do is at the end of this presentation, there'll be an email address, and you can email questions to that. Now, at the bottom right-hand corner of the screen, on every slide, you will see a slide number, and I've just circled one there so you can see it. And this is the number that you can refer to when you get email. So you could say, I have a question on slide number 56 of X amount, okay? So why don't we get started here? This is our agenda that we're going to cover today. We're going to go through an introduction of TGA. Then we're going to talk about how to run a typical sample. This is going to be using the experimentation, which is a very handy way if you guys haven't done it before to try that. And then we're going to go through some other topics like calibration, how to run samples without using the wizard, maintenance issues, etc. Now, first off, who should be attending this course? This course is designed for new users of TA Instruments Q-Series TGAs. And by new users, we mean less than 3 to 6 months. If you've been using the equipment for a year or more, we're probably not going to teach you a lot in this course that you may not know, but it might be a decent refresher. Generally, we recommend that the TGA should have been installed and calibrated by one of our certified TA Instrument service engineers. This way, after you attend this course, you can go and practice something that we've taught you, and it's kind of a better way to help reinforce the learning. After completing this course, what you should learn from this is a basic understanding of the TGA, ability to set up and run a typical experiment using the wizard, and an understanding of other issues such as calibration, sample preparation, etc. Now, just a definition, TGA, or thermogravimetric analysis, measures weight loss or weight gain as a function of temperature in a controlled atmosphere, or it could be as a function of time at a single temperature. Now, TGA is used to measure thermal stability, oxidative stability, and also look at composition of multi-component systems. It's used widely in the polymer and pharmaceutical industry, also in foods and biologicals, organic chemicals, and inorganics. Now let's go through how we would run a typical sample. This is our agenda for that. We're going to go through preparing the instrument, preparing and loading the sample, starting the software, using the wizard, and then using universal analysis, or UA, to analyze the data. Now this is a Q500, so we have two TGAs, Q500 and the Q50. Now if we look here, this touch screen that's standing on the Q500 is blown up here. This is our control menu that's shown here. So we've got controls for the furnace, load and unload sample pan, either tear a single pan or tear a tray if you have an auto sampler. This control will advance the pan or back up the pan. Platform calibration, other things can also be done from here. You've also got start and stop. You can also go to a display menu that will show the different signals, etc. If we look at a Q50 control, it doesn't have the display panel, but what it's got is this pad right here that's blown up here. So this is start, this is stop, tear, load and unload samples, and then close and unload and open a furnace. So those are the controls on the two instruments. Now, no matter which TGA you have from us, you need to hook up a purge gas. Now, here in the back of the instrument, we've got purge gas 1 and purge gas 2. Now, if you have a mass flow controller, this needs to be coming in at 20 psi, and then the flow rate is controlled from inside the instrument. If you don't have a mass flow controller, you need to control the flow rate from a bubble rotometer, but we will talk about that later. You also want to make sure the heat exchanger is hooked up. This is a picture of the heat exchanger here. This lid comes off, and you can fill this up with water and maybe a little bit of an algicide. In the back of the heat exchanger, you've got these tubes that connect to supply and the return side, and then they hook up also on the instrument, on the TGA. And then this cord here goes and plugs in on the back of the TGA. That's basically what you need to do on the basics of the instrument. Now let's go through preparing and loading a sample. One of the first things that you need to do is start off with a clean sample pan. We're going to talk about different sample pan types later, but here you can see a picture of us cleaning off a sample pan. This is a platinum pan, and the best way to clean it is to stick it into a torch. So here we've got it into a propane torch, and we're going to burn off anything that's on the pan. The next thing we need to do is put it on the tray and tare that pan. Now this shows the auto sampler, but even with a single load, whether it's a Q50 or a Q500 without an auto sampler, you would put it on there and then just hit tare to tare the pan. Next thing we need to do is get our sample together. So here we've got a picture of the sample vial, a little spatula in the pan. We're going to run calcium oxalate. I'm sure you guys have seen calcium oxalate before. It comes in your accessory kit. That's one of the reasons we run it. Everybody can go back and reproduce this experiment. Here's a picture of the sample pan with the calcium oxalate in there, even though it's kind of hard to see in this picture. Next thing we're going to do is put it onto the tray so that we can load it. And that's basically it for preparing the sample. Now the actual, some of the guidelines on preparing samples we will go through later in the other section, that third section. Now let's start the Thermal Advantage software. Now normally the Q-Series Explorer starts up when you start up your computer, so it's probably already running. But if for some reason it's not, what you would do is go to this icon that's on your desktop and double click on it, and that will start the Q-Series Explorer. As the Q-Series Explorer starts up, we get this box here. This shows all the instruments that are attached to your system. Here you can see we have a Q1000 DSC, another Q1000, a Q500, a Q10, a Q800 DMA, and then this Q500 is the one we're going to connect to. So we would double click on that, and that will connect into the TGA. Now here is one of three views that we get for the TGA. This is the default and what you'll normally see. This is the experimental view. And you can see here, this is the icon that controls that that's highlighted here. Now let me just go over a couple things on the screen, and then we're going to look at each of these 5 sections down here in a minute. But if we go up here across the top, we see we've got these controls. The first one is start and then stop. We have one that's reject, pause, and resume. You can see these 3 are grayed out because we're not actually running a sample. The next 3 are going to be the views, and we're going to talk about that a little bit later. This next one here is tare. All these others we're going to kind of go through as we go through, but anytime you hold the mouse over an icon, it will give you flyover help so you can see what's there. Across this status line here, you can see that we're the temperature of the sample, temperature of the thermocouple, and then right now we're not running, we're in standby mode. If we look at each of these windows and kind of talk about that, this window here is our signal display window. So this shows our method time, segment time, any remaining run time, shows our temperature, our weight percent, and our purge gas flow when we have that going. The next one down is method segments. So this shows this is what we're going to do to the sample. Ramp 20 degrees a minute to 1,000 is how this method's set up. If we have multiple segments, they'd be listed here. We'll also talk about how to change during a run as we start running. The next one down is real-time plot. So right now we would plot weight in milligrams versus temperature. And real-time plot would show up here and show our weight loss, etc. The center section is our summary procedure and notes page. This is where we would set up our sample run, and we can pick which template we want to use, go to the Procedure tab, set up our parameters, go to the Notes tab. We're going to go through filling this out later, but this is where that is. And you can see the Summary Procedure and Notes tab up here. The last one over on the left-hand side is our sequence. And this shows we've got 2 runs in this sequence. So if we have an auto sampler, we can have that automatically go and run 1, run 2, run 3, etc. Without an auto sampler, though, the sequence is still kind of nice. You can go up and set up multiple samples that you may have to run today, and then you can go down, and whatever arrow is pointed to here, when you hit start, it will run that. So even with the Q50 without an auto sampler, the sequence is very helpful. Now, I talked about that there were 2 other views. This is another view. You can see its icon highlighted here, but this shows real-time plot here, and this screen shows our running description, our signals, and our sequence. And then the last icon over here shows real-time plot full screen. This is probably a better way to look at real-time plot when you actually want to do that. Now, we've gone through the basics of the software, so let's go through the wizard to actually set up and run an experiment. We're back to our control screen, and this icon I've got highlighted is our experimental wizard. So if we click on that, it's going to take us into our wizard. Now, the first thing it does is it says, what type of run are you running? Are we going to do a conventional TGA run, a high-resolution TGA, or a modulated TGA? Now, we're going to just do a conventional run at this point, and you can see a description of all these here. So we select that, then we hit Next. Now it asks us what type of experiment do we want to run. This is our template that we're going to fill out. And we'll see when we do this manually how to do that also. But here, do we want a standard TGA ramp? Do we want a ramp with a gas switch, a heat and hold, or a stepwise isothermal? Now, this template will change based on what type of experiment that we picked up earlier. So whether we had a conventional TGA or a modulated TGA. We're going to do a standard TGA ramp, and we're going to click on Next. And then it asks us to enter our parameters. So we can enter heating rate and final temperature. Nice and easy, right? Okay. Now, this is typical, maybe 20 degrees a minute up to 1,000. There's 2 other choices here, advanced parameters and post-test. If we go to advanced parameters, it shows us our data sampling interval. Data sampling interval is from 0.5 up to and up at every half a minute. So this is the smallest number or the maximum data collection rate of 2 points per second. I said minute, half a second, sorry. We go to post-test, and this shows us our furnace conditions and whether we want to turn on air cool. Now, with an auto sampler, this will automatically gray out. It's going to open and unload at the end of each run and then turn on air cool if we have it checked for how long. Without an auto sampler, then you'll have a choice to leave this open and unloaded or to close it. If you have an auto sampler, and you can disable the auto sampler and leave it closed at the end of the run, and I will show that later. Air cool is important to help cool down between run. If you have compressed air hooked up to the air cool port in the back of the TGA, if you run from ambient to 1,000, it will cool down in about 20 minutes with the standard furnace to around 50 to 40 degrees. This just gives us a review. This is what we've set up so far. Is everything okay? If so, then we click Next. Now we enter our sample information. So we can put our sample name here, any further comment we've got. We click on this box here to browse and put our data file name. This is if we have an auto sampler, which pan we're going to run. We click on Next. Now we get to our notes page. This is where we put our operator name, the type of pan, extended text, and our purge gas flow rate. Now pan type is kind of important here. This is where we select which pan we're going to use, but it also selects our temperature limit. If we put in aluminum pan, it's going to limit our temperature to 600 degrees, where if we put in platinum or alumina, which are the ceramic pans, then it'll let us go all the way up to 1,000 degrees. For our mass flow controller settings, this is where we would put which gas we're going to use. So the balance is always going to be controlled with gas 1, and that's typically at 40 mils a minute for the standard furnace. our sample, in this case we're going to use gas 1 also, which is nitrogen, at 60 mils a minute. Now we're going to talk about purge gas later on and what to do if you don't have a mass flow controller. Now this is just a checklist that you go through and say, do I have my purge gas hooked up? Check. Have I tiered and loaded my sample? Check. Now I can just start the run. So if we click on Start Run, it's going to start that. Now you can see as we're running, we can see a couple things. Here's our method time, our segment time, our remaining run time. Here's our temperature that we're at, the weight that we're at, etc. Here's our real-time plot down here, or if we click on the real-time plot full screen, that will show that. So we can see that's the real-time plot. Going back to the experimental view, if we want to modify this method while it's running, we could do a right mouse click on that method. That'll pull up this. So if we decide that we don't want to go to 1,000 anymore, only to 800, we can click on that, change that to 800, click on Send Changes, and have that go into effect. Okay, now we've gone through running a sample. Now let's go using universal analysis to analyze the data. Now before we go into this, we have a complete Quickstart course on universal analysis. So I'm not going to describe every function of universal analysis. I'm not going to go through everything that UA can do. But I'm going to go through some basic stuff that TGA would use UA for. So after the run's ended, we click on this icon to start UA, go through and open our file. Here's our file that we're going to open. When we select that file, we get this preview here. So we can make sure we're selecting the right file. Once we click on Open, next thing we might want to do is look at our signals. We can see which signals we want to plot. So typically for TGA, I'll plot weight percent on Y1, and I'll plot the derivative of weight percent with respect to time or temperature, your choice, on Y2. And then here we're plotting temperature on the x-axis. For units, we can go in and plot weight in either micrograms, milligrams, or percent. I do it in percent, but you could look at it in micrograms or milligrams. Now if we look at the TGA, there's a box around the data of the TGA. There's a box around the active axis. So Y1 is now active. So any analysis that we do is going to be on Y1. So if we want to look at this weight change, so we would go to Analyze, Weight Change. We would pick our limits. So we use the left mouse button and drag the cursor to where we want to be. Now what you can do is you can actually drag the cursor off the curve, and it'll pick the first point of the curve. We pick the second point of the curve to be somewhere here on this flat section after the derivative comes back down. Once we do that, then we do a right mouse click in free space, and we get this Accept Limits option. So if we click on Accept Limits, we will get our weight loss. Now here we see our weight loss in percent and milligrams. We can do the same thing for the other weight loss steps. Now normally what you would do is when you do that, you would take this cursor and leapfrog it over to this one. That way this one stays the same place. Then when you're doing this weight loss, you take this cursor and leapfrog it over to here. So there's our 3 weight losses. Now maybe we want to look at residue. So we go into Analyze Residue, drag cursor all the way past the last data point and release. That'll pick this last data point on the graph, and there's our residue. If we want to do a temperature at a certain weight percent, so maybe we want to find where the sample has lost 10, 20, 5% of its weight. That's what we would do. So we would click on this. Then we can click on Manual Limits. That's by doing a right mouse click, and then we get the box. Click on Manual Limits, and then we can type in a number. So now we're going to look for a Y value of 75, which means a 25% weight loss, right? So we do that, and then it tells us at 495.54 degrees C, we see 75%, or we've lost 25% of the sample weight. Now maybe we want to look at the peaks of the derivatives. To do that, we need to switch axes. So we need to click on Y2 here and make that the active axis. Now we can go in and analyze the signal maxima. We would set our limits, do the right mouse click and set that. So we would get that peak temperature of the derivative. And we can repeat for the other peak temperatures. At this point, we can just go to File, Print to print the results. Okay, now let's go over some of the other topics. This is a list of other topics that we're going to go through. We're going to go through calibration. We're going to go through running experiments using templates. We're going to go through using custom procedures, going through purge gas considerations, sample preparation, auto sampler options, some maintenance, and some health issues. Now let's go through calibration. There's basically two calibrations that we're going to go through. There is a third, which is the platform calibration. We're not really going to go through that here. That just follows in steps in the software. Temperature calibration. Temperature calibration for TGA is done by using Curie points, and this is controlled by ASTM 1582. One of the things that you need to do first off is clear the temperature table before performing these calibration runs. And if we go to our experimental screen and go to Calibrate Temperature Table, we get, here's our table here. Now normally I like to write down these numbers so I can see how they compare, but here we can just click on Reset and that'll blank out that table. You want to choose Method in Condition of Furnace Close. This prevents the potential of the furnace opening into the magnet at the end of the run and damaging the TGA. Now remember, that's from our procedure and post-test. We'll click Closed for at the end of the run for the furnace. Now remember, if you have an auto sampler, you have to disable the auto sampler, and I'll show you that in a little bit here. For temperature calibration, we normally use a small lab jack to hold the magnet under the furnace. Now the vial here, this shows the nickel or alumel that would come in your kit, and these were the normal materials that we would use. After you make the run, you want to go into Universal Analysis, analyze the file. The Curie point is defined as the offset, and we're going to insert the numbers into the table. Now here shows this with in Universal Analysis. We ran both alumel and nickel. And so here we see our weight loss. We want to do an onset calculation, but what we're actually looking for is this offset. And we do that for both of these. So here's our temperature for nickel. Here's our temperature for the alumel. And we go back into Calibrate Temperature Table and go in and put these observed values in here. And here's our correct or standard values. And then hit Apply. The temperature calibration is done. Weight calibration. Weight calibration is you start from a wizard. You click on that little icon right there, Weight Calibration Wizard, and just follow the screen prompts. You use the weight that comes in the accessory kit. We're not going to show you all the screen captures for that. It just steps you right through, and you just follow the instructions on the screen. Now, we went through a while ago running samples using the experimental wizard. Now we're going to go through using the templates. So we go here and we pick what sample, what type of test. So we use a little drop-down box, and we've got choices of ramp, heat and hold. If you have high res, we'll have high res options. If you have modulated, we'll have modulated options. So we're going to select ramp. Then we would complete the sample information, like what the sample name is, where we want to store data, etc. Then we go to the procedure tab. Here we put in our heating rate and our final temperature. We could go to advance and post test like we did earlier if we needed to. Then we go to the notes page. This is our operator name, our pan type, and our purge gas settings. Once we get all that done, we go back and use a little green arrow here, like on your VCR, to start the run. Now let's talk about some custom procedures. For test mode, you select custom, and then we'd click on procedure. Now we go into the editor. So we click on editor, and it'll bring up this. So right now we've got select our ramp 20 degrees a minute to 500. We've got select gas number 2. Now if we want to continue ramping, we'd go over here and select ramp, and then we'd hold down the left mouse button and drag that. And that's what this is showing. I'm dragging that over into the screen. When I get it into the screen, below there you can see where this line is here. I'm going to release it. So just drag and drop. And now we can go in and say, okay, we want to ramp 20 degrees a minute up to 1,000. So that's all we need to do. And then we'd say OK, and there's our method. And you start the run same as before. Purge gas considerations. With the standard furnace, and the standard furnace is shown here. It's got, if you look inside, you can see a quartz, you can see the ceramic liner of the TGA. You can actually see that inside easily. For the standard furnace, we use 60 mils of gas to the furnace and 40 mils to the balance. Now this here shows which gas is hooked up, gas 1, gas 2. For the EGA furnace, and this is a diagram of the EGA furnace, it's got a quartz liner inside. It's a bigger round furnace. If you look in the top here, you can see the glass or the quartz inside there. For this one, we use 90 mils to the furnace and 10 mils to the balance. Now, if you don't have, so without a mass flow controller, gas 1 port purges the sample area only. Gas 2 port purges the balance area only. The balance always should be a dry inert gas. Now, if you don't have a mass flow controller, you need to control this purge gas flow rate with an external flow meter, like a bubble rotometer. If you have a mass flow controller, gas 1 purges both the sample and the balance areas. Gas 2 port is used when you want to switch to a different purge gas during a run, or if you want to use this different purge gas. Selection of gas on the notes page is critical for proper use of the mass flow calibration tables. And we showed that earlier. If you go to Tools and Instrument Preferences, this is where we say which gas is hooked up to each port. So that's which gas is hooked up here and which gas is hooked up here. If you go to the Notes page, this is what controls our flow meter, our mass flow controller. This controls what flow rate is going to it and what sample or what purge gas is going to the sample. Sample preparation. Generally, you want to maximize the surface area of the sample to improve weight loss resolution and temperature reproducibility. What does that mean? Powders are best. A powder that's spread evenly over the bottom of the pan is our best ideal sample for a TGA. If you have a large pellet or a large chunk of material, that can work as an insulator, so the inside may be at a little bit lower temperature than the outside of that, because that outside chars and insulates that sample. Sample weight, 10 to 20 milligrams is used for most applications, but you might want to increase that if you're using very small weight losses, measuring volatiles, etc. Now, most TGA instruments are going to have a drift of about 25 micrograms. And that's going to be about 1/4% of a 10 milligram sample. So that's why you want to look at sample weight. If you look at the drift of your TGA, now how do you do drift of TGA? Run an empty platinum pan, clean, empty, tared platinum pan, and look at the weight signal in micrograms. Other sample preparation tips, generally we use brass tweezers to eliminate any static effects. You always want to tear a clean sample pan before every run. Distribute the sample evenly over the bottom of the pan, as I mentioned earlier. If you're using a liquid samples, one thing you might can do is try a hermetic DSC pan with a pinhole in the lid. And that will allow the sample to come out of that, but it still keeps that aluminum's going to start melting above 600 degrees, so you want to limit your temperature to below that. Above that, the aluminum will start to melt and can alloy with the platinum. Sample pan selection. Platinum is probably the most useful and most commonly used. Relatively easy to clean, non-porous, but it can alloy with most metals. Alumina or ceramic pans are also used. They're larger samples. They are good for corrosive and inorganics, but they tend to be a little bit porous, so you can get samples stuck into the pan. There are aluminum pans designed for one-time use. Now these look similar to the platinum pans. They're lower cost and lower temperature limits. Now what happens if you put a aluminum pan on the TGA and you forget to switch it and you run it up to 1,000 degrees, the aluminum is going to melt and it's going to drop off the bale into the bottom of the furnace. So you want to keep those separate if you do that. Recently I was cleaning a pan with a sample torch and there were some pans mixed, and one of them was aluminum pan. And so when I hit it with the torch, it melted in my tweezers, and I didn't have a pan anymore. Auto sampler options. Now if we go to Tools, Instrument Preferences, there's an Auto Sampler tab. Now this gives us our sequence stop options where we want to open the furnace or leave the furnace closed. Now that's at the end of the sequence, not the end of a run. It's automatically going to open at the end of run if we're using the Auto Sampler. But see this checkbox here that says Enable Auto Sampler. If that's checked, it's going to open the Auto Sampler at the end of every run, or open the furnace at the end of every run. If it's unchecked, then it's going to allow you to control that, but it's not going to auto advance to the next run. Okay? Post-test conditions. Remember, this is what I was talking about. With using the auto sampler, this is grayed out. You don't have that control. Now, to build an auto sampler sequence, you use a pin. So you set up your first run, click on a pin, set up the second run, click on a pin, set up the third run, etc. Maintenance issues. Hang-down wire. The hang-down wire should be straight and centered in the furnace and the hang-down tube. Changing the hang-down wire is can be a little bit of a trick. It mainly just takes a steady hand and some practice. You might want to lay off the coffee that morning. You might need a magnifying glass or some better glasses, depending on your eyesight. But anyway, it's just hanging it on there. And in the manual, you can see it goes through a procedure. Or if your service guy or sales guy is in seeing you, you might ask him to show you how to do that. Cleaning the furnace. For the standard furnace, you need to take off and clean when necessary. In the manual, it goes through the steps of doing that. For the EGA furnace, you just want to run solvent through when dirty. So you would pull the little bottom off. There's a little plug on the bottom of the EGA furnace. You would run solvent through that, collect that in the beaker, run nitrogen through that to purge out and clean out that solvent, and then maybe heat it up to like 100 degrees or something to dry the rest of that off. The heat exchanger, typically I empty that every 1 to 3 months, empty that out so that algae doesn't form, but at least check it every couple of months and make sure that there's no algae forming. Now after you empty out that heat exchanger and you want to get started again, you need to prime out any air. So if you go to Control and Prime Exchanger, that'll sit there and run that heat exchanger, cycle it until it primes out all the air. Help pages. Now there's different help that we're going to talk about. Instrument error messages, the instrument log, online help, getting started guide, and then we'll talk about some phone numbers that you can call for help. Now this is instrument error message. It popped up, tried to start a run without a heat exchanger being plugged in, so it's got a heat exchanger flow error. Now if we go to our instrument log, which is this icon here, we can see all the things that have happened, like sample purge gas not reaching. But if we go to this heat exchanger temperature switch open, this flow error, if we click on that and hit error help, that will take us into here. And now we can see these are some of the potential problems and the solutions. So this will go through and help us try to solve our problems here. Now if we're in the middle of a method or a middle of any screen and we're going through filling out the screen and we have questions about it, we can hit the help. So if we click this help here, this is our online help. Now this is loaded onto your computer when you load the software. So if we click help, then we'll go through into creating custom methods. So we can go through and read this page. If we click on one of the blue highlighted, it'll take us into another link page. So here's help for that segment list. There's also a getting started guide. So if we go to help and getting started, that'll bring us up the instrument manual. If we click on chapter 3 for use, maintenance, and diagnostics, here's the help for cleaning a TGA standard furnace. So this steps us through how we should clean that. The help is really good. I would recommend you guys using that. Further help. Like I said, there's quick start courses for different techniques. We have quick start courses for all the different instruments. We also have for the data analysis, universal analysis, and the rheology data analysis. We're also starting some advanced courses, so be sure and check out our website. It's listed down here to keep an idea of what some of those courses are. We have a theory and applications training course given approximately every month in Delaware. Now, when you buy an instrument from us, you get a tuition to that course for one person for each instrument purchased. So if you buy a TGA, you get one person to the TGA course. This is a day course that talks about TGA. It goes in a lot more detail than what we did here, but this is a lecture-based course. It's not a hands-on course. If you have other people in your lab, or if you have an instrument that's been there a while and you want to attend this course, you can look on our website for information, but it's $400 per person per day. On-site training. You can have an application specialist from TA come to your site and give training. Now, typically, when I've done this, I've gone in and given part day of lecture, part day of hands-on, but it could be all lecture, it could be all hands-on. It's really based on whatever you want to do. Now, the typical charge for this is $1,500 a day plus expenses. So that would be typical for us to come in and do that. And typically we do a day per technique, even though sometimes I've done 2 days and covered 3 techniques. Once again, we can work that around you. As I said, check our website for other opportunities. Some other numbers. You can call the applications hotline, and the numbers here. Now, this is in Delaware in the U.S., and here's the hours that is manned. You can email questions to AnswerMan, either off our website or available direct here, answerman@taints.com. You can call our service hotline, and the numbers here and the hours are the same as above listed for the applications hotline. Now, sometimes you may say, yeah, I don't really know if this is a service question or an applications question. Call one of the numbers, and we'll get you the right person. Okay? Just call. If you have any questions, call us. That's what we're there for. We want to help you out and make sure you're getting the most out of your instrumentation. You can also call your sales and service representatives. They're a good base of knowledge for the instruments and can help you with a lot of the questions. Well, that's it. Thanks for attending. And join us for other training courses. For more information, visit our website. There's a lot of information on there, applications, briefs, etc. If you have specific questions over slides that we've gone over here, email us at this address here, webex2@taints.com. Put the slide number and what the question is, and, of course, what course it is, and we'll get back to you. Thanks a lot. Appreciate you joining us, and have a nice day.